In this video we will see control systems, state space analysis, basic concepts. Actually, one thing from gate point of view is like we should read the things which are generally asked. There is no point of reading things which are not very relevant. So this video and the basic concepts which I will be covering here will be very relevant as far as gate exam is concerned. We will see some example questions also, so that there is an ease, so that it becomes very easy to solve the gate answers, gate question. State space equation: x dot is equal to ax plus bu, y is equal to cx plus du. Here x of t or x is called as a state vector, y is called as output vector, and u is called as control vector. A is state matrix, B is equal to input matrix, D is feedback or feed forward. Matrix, and C is equal to output matrix. So these are some terms related to this. And x dot is equal to dy dt of x. It is a derivative of x. So these are some things, and we will understand remaining things when we solve some problems. Yeah. If we want to find transfer function given x dot is equal to ax plus bu, y is equal to cx plus du. Now from the state space form, and if I want to convert to transfer function form, so what do I do? Transfer function is given by c into si minus a whole inverse b plus d. This is the formula for this. Many number of times this question is asked, that we are given a state space equations and we are asked to find the transfer function. We will see a question as well. Suppose x1 dot x2 dot is equal to 0, 3, minus 2, minus 5. This is a x1, x2, ax plus u, y is equal to 2, 1, x1, x2. X1 and x2. We don't have a d. So suppose this is the question, and we are asked to find what is the transfer. Function? So as we know that if I want transfer function is equal to c into si minus a whole inverse into b plus d. Here this is 0, so our is c si minus a whole inverse into b. Now let us try to find out this. Now let us find transfer function c into si minus a whole inverse into b. So given x1 dot x2 dot is equal to 0, 3, minus 2, minus 5, x1, x2 plus 1, 1 u, and y is equal to 2, 1 into x1, x2. So 2, 1. What we have to find? Si minus a. Si is s0, 0, s minus a, 0, 3, minus 2, minus 5. What is this value? This is equal to s, 0, minus 3, minus 3. This is 2. This is s plus 5. So the value of Si minus A is this. So S minus 3 to S plus 5 whole inverse. This is C. This is Si minus A whole inverse to B. What is B? 1, 1. So now we have to find this. So before starting this, let us find S minus 3 to S plus 5 whole inverse value. This we have also discussed earlier in previous videos. The link of this video will be in the description. If I have a 2 by 2 matrix, how do I find inverse? So S minus 3 to S plus 5. To this 2 by 2 matrix, I want to find inverse. So how do I find? First, diagonal elements you change. Okay, S plus 5 and S. Interchange the position. Now minus 2, now put minus negative of this, and minus 3 you put 3, meaning off diagonal element you multiply it with the opposite sign into, this is 1 by determinant of this. What is the determinant of this? That is what? S into S plus 5 plus 6. So what is this value? This is equal to S square plus 5S plus 6. Now the inverse is what? 1 by S square plus 5S plus 6 into S plus 5, 3 minus 2 S. Now what do I need to find? I need to find this. So how do I do that? 2, 1 into 1 by S square plus 5S plus 6 into S plus 5, 3 minus 2 S into 1, 1. Okay. Now this is what? This is a 2 by 2 matrix and this is a 2 by 1 matrix. So the output will be 2 by 1. So 2, 1, 1 by S square plus 5S plus 6 into, output of this is what? 2 cross 1, S plus 5 plus 3, and this is minus 2 plus S. So 2, 1, I'm writing it like this: S square plus 5S plus 6 into, this is S plus 8 into S minus 2. Now this part, this we can write 1 by, this is 1 cross 2, 1 cross 2, and this part is 2 cross 1. The output will be 1 cross 1. So it will be like the multiplication of 2, 1 into S plus 8 and S minus 2 is 2S plus 16 plus S minus 2. This is 3S plus 14. So the thing is, the value is 3S plus 14 by S square plus 5S plus 6. So this is the transfer function y of S by x of S. I hope whatever I said in the last slide was clear. The thing is, like, we will have x dot is equal to bx plus bu, y is equal to cx plus du. To find transfer function, the formula of C is Si minus A whole inverse to B plus D. For our example, D was 0. So the transfer function formula is C into Si minus A whole inverse into B. To find inverse, so this is basically C cross whole inverse into B. Very simple. These are all matrix multiplications. So if I have a matrix A, B, C and D, 2 by 2 matrix, The process of doing an inverse of a 3 by 3 matrix is different, and the same thing cannot be followed, and I need to do, what do? I will replace D A, and I do minus C minus B, and this thing has to be multiplied with the determinant. What is the determinant? AD minus BC. Very simple. This is how you find the inverse of a 2 by 2 matrix. This inverse you plug it here, so C into, I have taken this, whatever is the value, D minus B minus C A 1 by AD minus BC into B. We plugged in the values of C and B, and we found the transfer function. Characteristic equation is actually defined as denominator of the transfer function. So transfer function is equal to y of s by x of s is given by c into si minus a whole inverse to p plus d. Now a characteristic equation is given by mod of si minus a. Now suppose if I want to do for our earlier example that x1 dot x2 dot is equal to 0 3 minus 2 minus 5 a x1 x2 plus pu y is equal to 2 1 2 1 x1 x2. Here a is what? 0 3 minus 2 minus 5. This is a, this is b, and this is c. So what I have to do, and I have already told you si is s0 0 s minus a. A is what? 0 3 minus 2 minus 5. This value is s minus 3 to s plus 5. Now we should find determinant of this. Find det. What is this? S into s plus 5 plus 6, that is s square plus 5s plus 6. So this is the character is equation. You can also find roots of this equation, right? So now this can be also written as 6 is what? 3 into 2, and so s square plus 3s plus 2s plus 6. So s into s plus 3 plus 2. I hope this is right. S plus 2 into s plus 3. So minus 3 and minus 2 are the roots for this equation. This can also be written as s plus 2 into s plus 3. So just a quick recap of what we have seen till now is that x dot is equal to ax plus bu, y is equal to cx plus du. This is also called as state space representation. For this, y of s by x of s is equal to transfer function is given by c into si minus a whole inverse into b plus d, and characteristic equation is given by mod of si minus a. Thank you. This is all it is. In the coming videos we will see controllability, observability, we will also see state transition matrix. So that's all. We will see these concepts in the coming videos. Thank you.